All right, let's look at the AP Calculus AB and BC FRQ for 2023. A bottle of milk is taken out of a refrigerator and is being warmed. So this is the increasing function of m, and here is our differential equation. So m is less than 40 for all values of t. Let's sketch a solution points through the point 0, 5, and so this is the y value 5. And so when you have a differential equation slope field and you have a point they have to go through, you just trace the slope field lines, and it's going to look something like that. All right, that's part A. Use the tangent line graph at m is equal to 0, or at t is equal to 0 to approximate m of 2, the temperature at 2 minutes. All right, so this makes me think of the y minus y1 is equal to the slope m time, except it's probably a bad s times x minus x1. This this is generally m, but I don't want to use m because it's the function. So y1 is 5, so y minus 5 is equal to the slope s. That looks like a 5. What should I call this function? F? No. Function, something for slope that I can remember it. D for derivative. There we go. Haha, we're gonna call this slope D. Uh, and so this is going to be equal to x minus x1, and x1 is just 0. And let's actually use the letters here. Let's call this m, which is the y variable, and instead of x, we're gonna do t, because these are the variables. Let's just put everything in terms of these variables, and this is just minus 0. Not dt, d times t. That's not gonna get confusing at all. Uh, let's see here. So now we have that, and we know that the derivative, or the slope, is dm dt. So d is equal to dm dt. And we're going to do this at t is equal to 0. This is a bit of a weird question. Hold on. We're basically substituting in this point here. So I'm just gonna put in 0, comma 5 as 0, comma 5. And so at that point, the slope will be 1/4 times 40 minus 5. 40 minus 5. And so that is our slope. And so then we can substitute this back into our equation. So this is going to be m minus 5 is going to be equal to 0. That's 35 over 4. 35 over 4 times t. And so if this is our tangent line equation, then we substitute in t is equal to 0 to get our approximation. So m of 2 is about 35 over 2, sorry, over 4 times 2, and then plus 5. And this is in degrees Celsius. Degrees Celsius. And so we could simplify this, but I'm not going to. I'm just going to leave it at that. All right, part C asks us to write d2m dt squared, and is this an over or underestimate? So, and we're going to use our second derivative. So, if dm dt is equal to uh, 1/4. Let me just simplify this. So this is going to be, just to save a tiny bit of time. So 10, dividing both sides by 4, 10 minus m over 4, m over 4. So d2m dt squared. We're going to just take the derivative again with respect to t. So the derivative of 10 is 0 minus m over 4 becomes 1/4 dm dt. Because we are differentiating with respect to m. And then I will substitute negative, I'll substitute dt back. So negative 1/4 times 10 minus m over 4. And that should be our answer. And this is an over or underestimate. This will be an overestimate because this is negative. So if we have, because just when the second derivative is a negative, we have an overestimate. So if you want to see a visual thing, we have a concave down function. This is concave down. And we have our derivative. And let's say we wanted to find estimate here, and this is concave down. So we take our tangent line and our y value that we expect is going to be up here when it's really down here. That's what a concave down function does. Use separation of variables now to find the particular solution with the initial condition m0 is equal to 5. So I'm going to leave it as this dm dt. So dm is equal to uh, the quantity 10 minus m over 4 times dt, multiplying both sides by dt here. Then we're going to integrate both sides. And so this is going to be m is equal to 10p minus, oh shoot, that is definitely, I was in the calculus mode. Let us not do that. Let's instead do dm over 10 minus m over 4 is equal to dt. There we go. And now we integrate. I was like, that is not right. So when we integrated this, we get the natural log of the negative natural log of the absolute value, because this is negative because of this negative in front of the variable there. The negative natural log of 10 minus m over 4 uh, plus c is equal to t. All right. And now we're going to exponentiate everything to get rid of Actually, let's move the c to the other side. Let's get the c. It doesn't really matter over here. So we're going to say this is d plus c. So then I can exponentiate this, and we're going to do the negative exponential. So we're going to exponentiate and multiply by a negative. So we have negative t plus c. And so this is going to leave us with 10 minus m over 4. Actually, I'm going to multiply everything by 4 here. So this is going to become 40, and this is going to become, uh, so that this is 40. This doesn't exist, and this is just going to be 4. This is my first time saying these FRQs. 1/4. We're going to move the 1/4 over here, so we can get rid of this. Get rid of this. This becomes 40. This becomes 40. This is going to be minus 1/4. Um, and so then we do the, and then we solve for m, because this is negative. We're going to add this to both sides, and then subtract it. So that should be equal to 40 uh, minus c e to the negative 1/4 t is equal to m and then plus c. Then we can pull the c out front if we really wanted to. And then we can solve for the c value by saying that c, let's move this c out front so we can actually do that. So this is going to be 40 plus c uh, e to the 1/4, negative 1/4 t is equal to m, but m naught is just 5, so c is 5. And that is it. No, it's not. It's not 5. It is, n because there's this plus 40. So we would solve this for c when we do 0 and 5 here. So c would be negative 35. So negative 35. Man, it's doable. It's just very negative 35. There we go. Took a second, but I got it.